Well, here's the periodic table. So you guys tell me first off, how do you know metals and non-metals? Starts letter J, I call it the J. Yep, metals and non-metals, it's the J. It's the break right there. Very good. So over here, so like for instance, sodium is a metal or non-metal? The sodium's metal, very good. Sodium's a metal. The other thing, so for instance, then, do you remember like if sodium forms an ion? What did you put at the top here? What ion does it form? A cation, very good. Awesome. And then what's the charge? Cation makes it positively charged. It's all of these guys do it. Positive one. Yep, it is a positive one. That was my whole point. How about oxygen? Is oxygen a cation or an anion? Does it form cation or anion? Forms an anion. Very good. It picks up electrons. What sort of anion does it form? What did you put up here at the top? A -2. Exactly. So it picks up 2 electrons. That's exactly right. So what's the atomic number of an atom? What's the atomic number of zinc? It is 30, atomic number, for instance, zinc. What does that mean? 30 protons and 30 electrons if it's neutral, exactly. That's the number of protons. You got it, the atomic number. Well, what's the mass number? And I'm not going to ask you the mass number of zinc, but when somebody says the mass number of something, what is that? It's 2 particles together. Neutrons. Neutrons. And protons. Yep. You got it. That's the mass number. Is the mass number for like all atoms of aluminum? Like, is it possible for you to have aluminum atoms with different mass numbers? Very good. Starts letter I. What do we call those? So if this changes, okay, then we can actually, and if this stays the same, we can have atoms of the same element, because that's what, okay, but this changes. What do we call that?
Isotopes.
Isotopes. You got it. Perfect. Yep, isotopes. So here's the deal then. We're going to kind of combine all of that we've been building up to, and we're going to be able to kind of, it's not really we're going to try to look at what's called a symbol, okay? And we're going to try to be able to say some information about it. Now, is there an element X? No. Only on the Powder Puff Girls. Yes. Professor, yes, I think he came up with that. But anyway, no, there is not. So kind of for shorthand, what we do is you're going to see some examples here where we put, instead of X, it's going to be the symbol of the element. The upper right-hand corner is going to be the charge. So for instance, you told me sodium is a +1. You might be Na +1, right? Oxygen's a -2, oxygen -2. And then over here on the left, we're going to see in the upper right-hand corner the mass number, and the lower left-hand corner the atomic number. Which one's bigger, mass number or atomic number? Mass number is going to be bigger, exactly. Yep, because that's protons, and that's protons plus neutrons.
So you guys told me, woo, this guy is number of protons, and this guy is number of protons plus number of neutrons. Yep.
All right. So here we go. So what does F stand for? Element-wise. Fluorine. It is fluorine. Yep. So fluorine, and then here we have a 19 and 9. What's 19? The mass number. Very good. What's 9?
The atomic number. So here, this is number of protons. This is number of protons. What, my pen's working nice today. Number of neutrons. Okay, yep.
So what would you put for what's its atomic number? 9. Very good. What's its mass number? 19. How many protons does it have? 9. How many electrons does it have?
Now, I will point out that it is a nonmetal, so it can pick up electrons, but the fact that there's nothing up here means that it's neutral. So with that in mind, how many electrons does it have? 9. Very good. And how many neutrons does it have? 10. How'd you get 10?
It's on the sheet.
Oh, oh my gosh. Thank you. We got 10 by taking 19, the big number, which is the protons plus neutrons, and subtracting the protons, which is 9. Okay? So, very good. Changing it up before we go on to calcium, which got all your stuff for calcium too. But what if, instead of being neutral, what if I put a -1 charge up there? Which of these numbers would change? Electrons. I'm liking it. So if electrons change, now what's the number? It's going to pick one up. It's going to be 10. It's going to be 10 electrons. And then here's where Exhibit A, I draw your attention to this exhibit. Which atom on the periodic table, if it's neutral, has 10 electrons? It is neon. So you see how that works? Fluorine picked up an electron. Now it still has 9 protons in its center, but now it's got 10 electrons, like neon. Okay, so it's still a fluorine something, but now it's got a -1 charge. And actually, the reason that the reason that nonmetals pick up electrons is so it can be like the rare gas in the period right in front of it. All right. So what does Ca stand for? It does stand for calcium. And you guys have the answers to this too? Okay. So protons is it's an atomic number there, 20. Electrons is protons. Yeah. So why is the electrons 18?
Does it have to subtract 2?
Yep. Electrons. It had 20 electrons as a normal calcium atom, and it subtracted 2 electrons, and now it runs around with a +2 charge, and it has only 18 electrons. Whereas my things look off, so the 18 goes with electrons. How did we get 19 neutrons? What do you think? 39 minus 20, yep. That gave us 19 neutrons, exactly. Yep. Ah, chlorine. Is chlorine similar to fluorine? Mm-hmm. It is. It's in the same, remember, it's in the same group, same family. They both pick up one electron, form a negative one charge. Okay. So, of course, protons is 17. Why is the electrons 18?
Add in one.
Added one. Exactly. 17 plus 1. Cool. Why is the neutrons 19? Subtracted. 36 minus 17. That's it. So, you know, it seems kind of gimmicky, but it's real. When you see something kind of shorthand written like that with the symbol of the element and the charge maybe in the upper right hand corner. If there's no charge, remember that's neutral. All right, so I have a little video to show you in a minute. I think I'll show you the video and then we'll finish up. And the way it works out is the more protons it has in the nucleus, the more that atom weighs. Makes sense, right? We already introduced the symbol U. What does U stand for? The abbreviations are AMU. What's that? Atomic mass units, yep. Exactly. And we already kind of said that a neutron weighs about 1 AU and a proton weighs about 1 AMU, or 1 U, 1 AMU. Remember, I use those interchangeably. How much does an electron weigh? Basically zip. Electrons are kind of massless, we call it. But so I need to talk about one more number in the box that for the periodic table. So we picked on carbon a lot, so let's pick on carbon again. So carbon is over here. It has 6 protons, and for carbon on this periodic table, you see 12.011. That actually is how much a carbon atom in general weighs in atomic mass units. So we could take 12.011 and we could put U or AMU after it. That's how much a carbon atom weighs. So they're very small, okay? So we can't use like kilograms or what we could, but, and we do sometimes, but AMUs is a good unit to use. Now, the thing about it is, and we can pick on carbon. Have you ever heard of carbon? Is it carbon 14? Yeah, I think it's carbon 14, not carbon 13. Oh, I don't know, but carbon dating. Okay, so there are different isotopic forms of carbon. What is an isotope? It's something that has changed the number of neutrons in its nucleus. So you like, oh my gosh, so there's a heavy carbon and a light carbon. Yes, the answer is yes. So these decimal numbers, actually, we use some math. I'm not going to pull you through it. It's not a very hard math problem. But what we have to do in order to come up for carbon with that 12.011 is to go out and kind of see, oh, we got this sort of carbon, we got that sort of carbon. How much do we have of each? And that's what we call their abundance, and how much do they weigh? And then we do a little problem to come up with an average, a weighted average, no pun intended. So, so that's what those decimal numbers are. So I have some questions for you, and we'll be using that decimal number in some problems. You kind of figured that coming up. So find lithium. Okay, what is what is the mass of a lithium atom? What do you think? Yep, I'm liking 6.94. And this was kind of, if you were handing this in, I won't have you hand it in, but then then the units, I'm going to just put U's. But like I said, if you see, oh, darn it. Ugh, heavens. Nope, that's not what you told me. So you told me 6.94. I'm going to go ahead and put U's, and sometimes you'll see AMUs instead of U's, but it means the same thing. How about an iron atom? How much is it weigh? An iron atom. Yep, I got 55.845. Is that what you said? Yay, thank you. And I'm going to go ahead and put U, or AMU is the same thing. Last one, uranium. It's a heavy sucker. 238.03. Yep. Use or AMUs. Perfect. Perfect. So I think you guys have this slide. So as you can see, and I have some screenshots. Let's see. Exercise 16 and 18. So over here, 16 and 18. Give the total numbers of electrons. Okay, that you should be able to do 16 fine. Use the periodic table to find the atomic mass. Now, atomic mass is what you guys just told me, the weight. Atomic mass, atomic number, or atomic number, protons, okay, that should be fine. And then 303 is this table right here. So it's kind of, I'll just kind of turn you loose. You should be able to actually fill in all of those blanks. Okay? So, for instance, they're kind of fun. So the second column, what would be the element there? What element is that? The second column. It is phosphorus. See how she got that? Yep. So I'll just kind of turn you loose, and those will be due when we meet in here on Wednesday. Okay? And Thursday's lab, we're going to do, it's one of our dry labs. We're going to talk about the periodic table and elements and stuff, so it should be fun. And that's all I got. Thanks for switching rooms. And make sure Ashley knows.